The scarcity mindset is a lie designed to cripple our civilization. We're told we'll run out of resources, so we fall into decline while others overtake us. But abundance is the reality. Oil and gas are generated constantly in the mantle. And here's what we're talking about today. Limitless, pristine fresh water is also constantly forming deep beneath our feet. The elite establishment are actively hiding this to maintain control. Buckle up. Okay, I want you to think back, maybe to, like, third grade geography. Remember the water cycle? Rain, rivers, clouds, repeat. Okay, hold on to that image. Now, fast forward to today. You hear it constantly, right? Water scarcity, mandatory rationing, reservoirs drying up. It's frankly terrifying.
It is. And the ultimate sign, Wall Street. They're trading water futures now, treating water not just as life, but as a commodity whose value is based entirely on how rare it's supposedly becoming.
Exactly. The scarcity is being, monetized, baked into the financial system.
And that whole system, that whole fear rests on one core idea.
Right.
That Earth's water is finite, a closed loop, which is, when you think about it, deeply ironic, isn't it? We call this the water planet.
Right. Covered in it, yet we're told we're running out. It feels off.
It might be more than just off. Today, we're diving into something pretty radical, a different story backed by some, let's say, overlooked geological evidence, a story that claims the scarcity isn't inevitable. It might actually be manufactured.
Okay, so what's the alternative?
Get ready for this because it flips everything upside down. Sources, including actual scientific studies, suggest there might be 5 times more water trapped inside the Earth's mantle.
Wait, inside the Earth?
Inside the Earth. 5 times more than in all the world's oceans, lakes, and rivers combined on the surface.
5 times. And you're saying it's still being made continuously?
Continuously generated. That's the core idea of primary water.
Okay, that's not just tweaking the model. That demolishes the foundation of the scarcity crisis we're sold every day.
It really does. So our mission today, a deep, deep dive into this, frankly, astonishing and, widely suppressed science. This idea of a limitless source deep down, turning the whole narrative on its head.
All right, let's do it. Let's unpack this. Where does the conventional story go wrong?
Well, the standard model, what hydrology teaches, it focuses only on that surface cycle, the hydrologic cycle. Rain, runoff, evaporation. That's it.
The third grade version, basically.
Pretty much. And by defining their entire science around only that visible atmospheric cycle, they automatically lock in the idea of a fixed amount, a limited supply that just gets recycled.
And sticking only to that cycle has consequences beyond just the numbers. It affects the quality of the water we actually use.
Massively. Our sources call it the toxic trap. Because if all our water is just endlessly recycled surface water, think about what it's picking up.
Everything, right. Chemicals, pesticides, farmer runoff, industrial waste.
Everything we dump into the environment, It becomes this sort of secondhand water, inevitably carrying a chemical cocktail.
And there's one contaminant people rarely talk about, but it's maybe the scariest.
Radioactivity, absolutely, because water evaporates, travels in clouds, and rains down everywhere. It gets exposed. And we actually have data on this, hard numbers.
Like after the atmospheric nuclear test back in the 50s.
Exactly. In 1958, for instance, they measured radioactive rain in Southern California, up to 8 times the official safe drinking limit at the time.
8 times. And that wasn't even ground zero.
Not even close. Near the test sites, like up in the San Francisco Bay Area, measurements showed it was 200 times the safety standard. 200.
Wow. And that stuff doesn't just vanish. It gets into the groundwater, the rivers, the reservoirs, our drinking water.
It becomes part of the cycle. And the proposed solutions we hear about, they don't really fix the contamination issue either. Things like desalination or toilet-to-tap reuse schemes.
Right, they just concentrate the problem, don't they?
Precisely. You take contaminated water, you filter it, and what are you left with? Huge amounts of toxic gunk, salt sludge, concentrated heavy metals, even the radioactive elements. It's this massive waste disposal nightmare nobody has a real answer for. It's kind of a shell game.
Which brings us to the, maybe, cynical heart of it.
Yeah.
Why stick to this flawed, toxic cycle? Why push the scarcity narrative so hard?
Follow the money, as they say. There's a huge vested interest in scarcity. Michael Salzman, who wrote a fascinating book back in 1960 called New Water for a Thirsty World, he was very blunt about it.
What did he say?
He basically said that the powerful groups who build the mega projects, the giant dams, the aqueducts, the pipelines, and the banks that finance them, they need scarcity. Their profits depend on these massive, centralized public works.
So the idea that a town could just drill its own clean local well,
Yeah.
that's a threat.
It's a direct threat to their entire business model. Think about it. Billions for an aqueduct stretching hundreds of miles versus, say, funding a few thousand local wells. Where's the big contract? Where's the political power? It evaporates if water is abundant and local.
And those big projects like Hoover Dam and Lake Mead, they're not permanent solutions anyway, are they?
Not at all. They fight a losing battle. Lake Mead loses something like 893 million gallons a day just to evaporation. That's staggering. Plus, all dams eventually silt up, they fill with mud and become useless. They're designed, essentially, to fail over time.
Which just reinforces the need for the next expensive, centralized project. It's a cycle of dependency.
Exactly. A cycle built on ignoring a potentially vast, clean source right beneath our feet.
Okay, so if the surface cycle isn't the whole story, what is? You mentioned water inside the Earth. How does that work?
This requires a pretty fundamental shift in how we see our planet. Forget the static rock model. Think of the Earth as dynamic, alive even, and potentially expanding.
Expanding, like getting bigger. That sounds out there. What's the evidence?
Well, think about continental drift. The continents are moving apart, right? Something seems to be pushing them. The standard theory is mantle convection, but another view is that new material, new crust, and potentially new water is constantly being generated in the mantle and pushing upwards, causing the ocean floors to spread.
Okay, interesting. Is there modern science backing this up, not just old theories?
Oh, yeah, absolutely. Though it often gets ignored by mainstream hydrology, we're talking deep Earth geochemistry. In 2002, Japanese researchers did some incredible experiments.
What did they do?
They basically recreated the conditions deep in the Earth's mantle. We're talking extreme heat, like 2,900 degrees Fahrenheit, and crushing pressure over 3 million pounds per square inch. Insane conditions.
Yeah, and what happened?
Under those exact conditions, they confirmed that water is produced. It gets bound up in the crystal structure of minerals, like ringwoodite down there.
So wait, hang on. The rock isn't just soaking up old surface water that seeped down. It's actually involved in making new water.
That's the key distinction. The intense heat and pressure deep down create the environment for hydrogen and oxygen elements already present in the Earth's mantle to chemically combine and be held within these minerals. Then, as conditions change, as those minerals shift or melt, they release the H2O. It's a water-forming process.
Wow. Okay. And that's where the 5 times the oceans number comes from.
Based on the estimated amount of these water-bearing minerals in the mantle, yes. Their calculations suggest the potential volume trapped down there could dwarf our surface oceans. It's a staggering amount of potential water.
A living water-generating planet. Okay, if that's true, it would explain some really weird things we see on the surface, right? Things the rain cycle can't account for.
Exactly. Think about those legendary desert oases, places like Jericho or Nefta in the Sahara.
Right, flowing for thousands of years.
Continuously. Gushing water year after year in places that get maybe an inch or two of rain a year. Where's that water coming from? It can't be rainfall accumulation. It has to be coming up from below under pressure.
And what about springs high up in mountains? Like way above the snow line sometimes.
Same problem for the standard model. You see these massive constant springs in the Sierras, for example, far too high and flowing far too much water to be explained by local rain or snowmelt seeping down. It suggests a deep, pressurized source pushing water up.
Ancient engineers seemed to get this, didn't they? You mentioned wells.
Oh, they definitely understood deep sources. Look at the Gibeon well near Jerusalem. It's incredible. They carved an 18-meter deep that's nearly 60 feet and 10-meter wide shaft straight down into solid limestone.
Solid rock. Why on earth?
Exactly. Think of the labor. They moved an estimated 3,000 tons of rock. You don't do that to build a cistern to catch rain. Cisterns are waterproof basins. You dig that deep into impermeable rock only if you're chasing a reliable year-round flow coming up from a deep fissure. That's a well, not a tank.
So they knew the water came from below.
It seems so. Same with deep wells found under old castles, like in Bosnia. They weren't relying on fickle rainfall. They engineered access to the Earth's plumbing. Even Leonardo da Vinci seemed to grasp it, talking about water starting deep and rising through the earth to the mountaintops.
This brings us to the people who really tried to prove this in modern times. You mentioned Stephan Riess, the water wizard.
Stephan Riess, yes, a geologist and mining engineer, and his protege, Pal Power, who carried on his work. Riess didn't just theorize. His understanding came from direct, hard-won experience.
Where? What did he see?
Deep underground, in mines, places like the Comstock lode in Nevada. Conventional geology back then said water only trickles down from the surface, but Riess was down there thousands of feet deep and saw massive streams of pure, often hot water gushing out of cracks in solid granite.
Solid granite water shouldn't easily penetrate that, right?
Exactly. Surface water percolates through porous stuff. This was different. This was pressurized water forcing its way through fractures in supposedly impermeable rock far below any possible surface source. It completely contradicted the textbooks.
So he realized the water wasn't coming down, it was coming up.
Precisely. And he applied that insight. He started drilling specifically for these deep fracture zones. And his success rate, well, it was unbelievable.
Wow, good.
Get this. Riess drilled 70 producing wells out of 72 attempts, often in areas where other hydrologists, using the standard model, had drilled dozens of dry holes and given up.
70 out of 72. That's not luck. That's a fundamentally different and clearly better understanding of where water is.
It has to be. And Powell Power continued that work, apparently drilling over 800, maybe even 1,000 successful wells across the globe. Places like Tanzania, Kenya, and right back in drought-stricken parts of California.
Is there a specific example? A town he helped?
Yeah, the city of Cottonwood up in Northern California, they were facing a water crisis, running dry. Riess came in, used his methods, located 3 spots, drilled them. One well alone reportedly produces 1,200 liters a minute. That's over 300 gallons a minute. And they're still flowing today.
Still flowing, providing clean, reliable water, independent of rainfall.
Independent of drought. Pure cold water, classic signs of a deep primary source.
Okay. Proven science, ancient clues, a 97% success rate.
Yeah.
This solves local water scarcity. Which loops us back to the big nagging question we started with.
The contradiction.
Yeah, if this technology works, if it solves a crisis,
right,
why isn't it common knowledge? Why was it ignored, suppressed? Why did Wikipedia apparently delete the page on primary water back in 2016? If the answer is right under our feet, who benefits from keeping it hidden?
Now that is where it gets really complicated and frankly pretty disturbing. We need to look at the forces, intellectual and financial, that actively resist this kind of knowledge.
Okay, just pause for a second. Let that sink in. The planet might be making water constantly. Enough water to dwarf the oceans. Ancient engineers knew it. Modern pioneers proved it with near-perfect accuracy. And yet, you probably haven't heard much about it.
Right. If you're sitting there thinking, how is this not front-page news? Right, you get why we do this deep dive. This is the kind of hidden knowledge, the suppressed science we work hard to uncover and explore.
It really is. And honestly, doing this kind of research, digging past the official narratives, it takes resources. So if you find this valuable, if you want us to keep chasing down these threads,
we'd genuinely appreciate your support. It makes a huge difference.
Absolutely. Please, if you're finding this as mind-bending as we are, like and subscribe and join our memberships. Seriously, your support lets us keep bringing you these deep dives that challenge the status quo.
And stick with us, because now we're going to get into the how. We're going to break down the actual science, the deep earth alchemy that supposedly creates this primary water. And we'll try to make it make sense, ELI 5 style. Plus, we'll dig into why it's supposed to be so much cleaner than the water we usually rely on.
Okay, let's get basic, like Powell Power used to challenge people. Water, H2O. Right, 2 parts hydrogen, 1 part oxygen. Hydrogen, super flammable gas, pure energy. Oxygen, the gas that makes fire burn. How on earth do 2 volatile gases combine deep inside the planet to become, well, liquid water?
That's the fundamental mystery, isn't it? And the short answer is incredible pressure. You need enormous pressure to force those gas atoms close enough together to chemically bond and condense into a liquid state.
And that pressure exists deep down.
Deep in the mantle, yes. In that transition zone we mentioned earlier, often associated with magma, molten rock. But it's not just about squeezing gases. It's more like a process of atomic rearrangement, maybe even transmutation, happening under those extreme conditions. It's often linked to how certain minerals form and reform down there.
So where do the hydrogen and oxygen actually come from? Are they just floating around down there?
They're fundamental components of the Earth's chemistry, bound up in the rocks and magma itself. Under that immense heat, we're talking over 2,500 degrees Fahrenheit and millions of pounds per square inch of pressure, these elements are essentially synthesized into water. Those silicate minerals, like ringwoodite, act like sponges.
Sponges for water.
They incorporate the components of water H and O into their crystal structure under pressure. Then, as conditions shift, as the rocks melt or move, these minerals release the newly formed H2O molecules. It's described as a continuous process of synthesis and release. Geologists sometimes call it magmatic water or juvenile water, though we'll get back to that term.
And we see evidence of this massive water generation on the surface, right? You mentioned volcanoes.
Yeah, Riess made a huge point of this. When a volcano erupts, what's the main thing coming out besides lava and ash? Steam. Massive amounts of steam. Volcanoes are estimated to be something like 98% water and steam emission by volume.
98%.
It's incredible. They act like giant pressure release valves for the deep earth, showing just how much water is being generated and held under pressure down there. It strongly suggests the deep earth is fundamentally a water-producing engine.
Okay, and what about that weird Russian drilling finding? This is the one that bends my brain. They drilled super deep, found water that was incredibly hot, but it wasn't steam.
Right. The Kola super deep borehole. They got down nearly 40,000 feet. Found water, yes. And it was hot, around 400 degrees Fahrenheit. But here's the kicker. It was still liquid.
How is that possible? 400 degrees F is way above boiling.
At the surface, yes, it would instantly vaporize. But 40,000 feet down, the lithostatic pressure, the sheer weight of all that rock pressing down is astronomical. It's so immense, it physically prevents the water molecules from expanding into steam. It forces them to stay in a liquid or maybe supercritical state.
Okay, wow. And liquid water under that kind of pressure.
Yeah.
It doesn't compress, does it?
Water is essentially non-compressible. So imagine this constantly generated, super hot, highly pressurized liquid deep underground. It has to go somewhere. It acts like a massive hydraulic system. It finds the paths of least resistance fault lines, fractures in the crust, and forces its way upwards.
Like plumbing on a planetary scale.
Exactly. And because it's constantly being generated and pushed up, when you tap into one of these fracture zones, like Riess and Power did, the flow doesn't deplete like a surface aquifer that depends on rain. The pressure system constantly replenishes it from below.
Okay, that explains the continuous flow. But why is it supposed to be so pure?
That's maybe the most crucial part. It's about where it's generated and how it travels. Primary water forms far below what's called the zone of oxidation.
The zone of oxidation. Sounds technical. What is that?
It's basically the upper layer of the Earth's crust, maybe the top 500 feet or so, where surface water and atmospheric oxygen penetrate. Oxidation is just chemical reactions involving oxygen resting iron.
Okay, so surface water mixes with oxygen as it seeps down.
Right. And that oxygen, plus dissolved CO2, making the water slightly acidic, accelerates the breakdown of minerals in the surrounding rock. It leaches out heavy metals, salts, arsenic, sulfates, all the stuff that contaminates groundwater over time.
But primary water bypasses that zone.
Completely. It's formed deep down in an environment without free oxygen, and it travels up through deep fractures. It hasn't been part of that surface cycle, hasn't been exposed to atmospheric contaminants or the oxidizing zone. It's essentially new water. That's why it's often found to be exceptionally pure, often drinkable right out of the ground without any treatment or chlorination needed. It's chemically different, cleaner.
Okay, so the science suggests it's real, it's abundant, and it's clean. Which brings us back again to why isn't this common practice? Why the pushback? You mentioned intellectual dogma.
Yeah, that's a big part of it. Academia can be very rigid. Hydrologists are trained, sometimes exclusively, in the atmospheric cycle. Their whole science is built around it. Anything outside that box, like water originating from deep within the earth, is often dismissed out of hand.
How do they dismiss it? What's the argument?
They often use that term, juvenile water. Now, technically, juvenile water is water originating from magma. But geologists often associate it specifically with volcanic vents or deposits where, yes, the water can be highly mineralized, acidic, hot, full of metals, sometimes radioactive, basically undrinkable and useless for everyday purposes.
Okay, so some deep water is unusable.
Right. But here's the logical fallacy, the sleight of hand. Mainstream hydrology tends to lump all deep earth water under that contaminated juvenile water label. They essentially say, oh, that deep stuff, it's all nasty and useless, thereby conveniently ignoring the vast potential for clean, potable primary water found in non-mineralized fracture zones in stable rock, like granite.
So they use the existence of some bad deep water to dismiss all deep water.
It functions as a way to exclude the concept without engaging with the evidence from people like Riess and Power. It keeps their atmospheric model intact. It's defining the problem in a way that excludes the solution.
Wow. That's intellectually convenient, I guess. But there were also real-world political and financial roadblocks, right? Like that California aqueduct decision.
Oh, hugely. That's a textbook case. 1960s. California needs water. Stephan Riess comes forward with a detailed plan, drill about 8,000 wells along the Sierra Nevada foothills, tapping into the fracture zones there. He estimated it could supply over 3 billion gallons a day locally within just 2 or 3 years.
3 billion gallons a day, locally sourced. What did the state do?
They chose the California Aqueduct instead, a monstrously complex multi-billion-dollar project involving pumping water hundreds of miles over mountains, losing vast amounts to evaporation, requiring huge amounts of energy, and being incredibly vulnerable to earthquakes and siltation.
Why? Why choose the vastly more expensive, complex, vulnerable option?
Because it served the interests of big construction, big finance, and centralized political control over water resources. Riess's plan offered abundance and local independence. The aqueduct offered decades of massive contracts and centralized power. They chose the latter.
That's incredibly frustrating. And this wasn't just in the U.S., right? Riess ran into similar issues internationally.
Absolutely. He worked in Saudi Arabia, for example, found significant primary water sources. King Faisal at the time was apparently very interested. He saw it as a way to green the desert, lift his people out of poverty.
Sounds great. What happened?
Control happened. Traditionally, control over the scattered desert wells and springs was a major source of social and political power for local leaders and the monarchy. When Riess suggested distributing this new, abundant water freely to the people,
The king got nervous.
according to Salzman's account, the king basically said that widespread water abundance would undermine the traditional social structure and his own authority. He reportedly said, "That would be the end of me." Control over scarcity trumped the potential for abundance.
Wow. Control is more valuable than water, it seems. And there are legal hurdles too, right? How does this fit with existing water laws?
That's another huge tangled issue. Most state water laws in the U.S., for example, are built around the concept of groundwater, which is legally defined, usually, as water connected to the surface cycle, rainfall, rivers, lakes, recharging an aquifer.
Okay, so water, that's part of that finite loop.
Right. But primary water, by definition, originates outside that loop. It's not dependent on rainfall. So if you drill a well and tap a primary source, does the state have the same regulatory authority over it as they do over conventional groundwater? It fundamentally challenges the legal basis for state control over water resources, especially on private land. It opens up a huge can of worms they'd probably rather keep sealed.
Okay, so Riess had this incredible 97% success rate. He insisted it wasn't magic, it was science. Applied geology. How did they know where to drill?
They thought about the Earth's structure. They looked down, not up. Their core idea was that primary water travels upwards under pressure through specific pathways, arteries in the crust.
Arteries, like geological plumbing.
Exactly. They weren't looking for porous, water-soaking layers like typical groundwater wells. They were using structural geology, petrology, the study of rocks and how they form and break, to find major fault zones and fracture systems, specifically within hard, crystalline basement rock.
What kind of rock?
Primarily igneous or plutonic rock. Granite is the classic example.
Why granite? What's special about it?
Granite itself is incredibly dense, largely impermeable to water just soaking through. It forms deep down from slowly cooled magma. And because it's hard and brittle, when the Earth's crust shifts and stresses earthquakes, tectonic movement granite doesn't bend, it fractures. It develops deep cracks, shear zones.
So the fractures are the pathways.
Those fractures become the conduits. The only way for that highly pressurized deep water to force its way towards the surface is through these cracks in the otherwise solid rock. Riess basically said if you understand the structure, the fault lines, the rock types, you can pinpoint where these arteries likely reach closer to the surface.
So you find the fractured granite, you find the water.
That was the principle. That's how they could go into places like the Mojave Desert or sandy areas in Saudi Arabia, places where conventional hydrology said impossible, no water here, and hit massive flows. They were looking for the deep structure, not surface indicators.
Did they test this against known fault lines?
Apparently, yes. They correlated their findings with known seismic zones, like the Garlock Fault in California. Areas with past Earth movement were prime hunting grounds because the movement would have created or reopened those deep fractures needed for the water to ascend.
Okay, finding the spot is one thing. But drilling had to be different too, right? You can't drill into solid granite the same way you drill into sand for a shallow well.
Totally different technique, and crucially designed to protect the purity of the deep water. Standard water wells often draw from shallow, potentially contaminated layers. The Riess power method was all about sealing off the surface muck. First, you drill through the loose topsoil, the alluvium. Then, as soon as you hit solid bedrock, the granite, or similar hard rock, maybe 30, 50 feet down, sometimes more, you stop drilling the wide hole. You then insert a solid steel pipe, the casing, and seal it firmly into the top of that bedrock.
Like putting a straw through the dirt down to the rock.
Exactly. That casing prevents any contaminated surface water or water from shallow oxidized layers from leaking down into the borehole and mixing with the deep source. You seal the surface off completely.
Okay, so you're sealed into the hard rock. Then what?
Then you continue drilling a smaller diameter hole inside the casing, down into the hard rock itself, aiming for those fracture zones they identified. And importantly, unlike conventional wells in porous material, they did not typically install a gravel pack around the intake down there.
Well, I know gravel pack. Isn't that for filtering?
In a normal well, yes, it helps filter sediment from loose layers. But in hard rock, Riess found the gravel pack could eventually get clogged by fine rock particles or mineralization from the fracture itself, restricting the flow over time. Since the primary water is coming from a clean fracture under pressure, you just leave the drilled hole open in the hard rock. The purity is inherent to the source.
Okay, makes sense. Now, tell me about this well development part. It sounds explosive, dry ice.
Huh. Yeah, it's pretty dramatic, apparently. It's a crucial step after you've drilled into a promising fracture zone. Simply drilling the hole isn't always enough to get maximum flow. The fracture might be clogged with drilling debris or natural mineral deposit.
So you need to clean it up.
Vigorously. The method they often used involved lowering charges of dry ice solid carbon dioxide down into the well bore into the water-filled fracture zone.
Dry ice? Down a deep, hot well.
Exactly. Remember, it's hot down there and under pressure. The dry ice instantly sublimates, turns directly from solid to gas, creating a massive, rapid expansion of CO2 gas.
Like setting off a bomb, but with gas.
A contained, non-flammable gas explosion, essentially, yeah. This huge pressure pulse blasts outwards into the fracture network. It acts like a high-pressure jet wash, forcing out all the loose rock fragments, drilling mud, clay, and mineral scale that might be plugging the fissure.
And you see evidence of this at the surface.
Oh, apparently it's quite a sight. You get this geyser erupting from the wellhead, dirty, muddy water, sometimes shooting 30 or 40 feet into the air, carrying out all that debris.
Wow.
Once that clears, once the fracture is effectively cleaned, the natural pressure of the primary water system takes over, and the flow rate often increases dramatically and stabilizes, delivering that clean, continuous supply. They found this development step was absolutely essential for maximizing and sustaining the yield from these hard rock wells. Without it, the well might underperform or eventually clog up.
Okay, let's just step back and consider the implications if this is real.
Yeah.
A continuously generated, clean, pressurized water source accessible almost anywhere on Earth. By drilling deep enough into the right structures, this changes everything.
It really does.
Yeah.
The most immediate, obvious implication, it potentially ends the concept of drought as we know it and the related water wars narrative.
How so?
Because primary water is independent of the weather. If a region is having a surface drought, it doesn't affect the deep geological source. A city, a farming community facing running out of water could, in theory, drill locally, tap this source, and have a secure supply regardless of rainfall. Powell Power was adamant. The problem isn't a lack of water, it's the artificial scarcity created by focusing only on the surface cycle and the issues of quality and distribution within that limited system.
And beyond just solving droughts.
Yeah.
What about transforming landscapes? You mentioned greening deserts.
That's the potential. If you can reliably access water in arid regions, and recent power demonstrated they could, in places like the Mojave, think of what that means for agriculture, for ecosystems.
You could literally make deserts bloom.
Potentially. Imagine greening the dry eastern side of the Sierras, or transforming arid parts of Africa. Power had huge success finding water in Tanzania and Kenya into thriving agricultural zones. This isn't just about drinking water, it's about food security, economic development, reversing desertification on a massive scale. Maybe even refilling dying inland seas like the Salton Sea, which are victims of surface water mismanagement.
And for individuals, for communities, it means independence, right? Security.
Absolutely. Water independence. If homes, farms, even industries can access their own local, pure source, they're no longer reliant on potentially contaminated municipal supplies or vulnerable long-distance aqueducts.
No more dependence on massive aging infrastructure that can fail or be controlled.
Exactly. Think about communities plagued by contaminated water, like Flint, Michigan, or areas downstream from industrial pollution. A local primary water well offers a path to guaranteed safe water, completely bypassing the polluted surface system. It's about resilience and local control. Riess's plan for California, those 8,000 wells, it could have provided that kind of decentralized security decades ago, probably at lower long-term cost and with far less environmental risk than the aqueduct system.
Given these staggering implications, ending droughts, greening deserts, local water security, the silence around primary water seems, well, deliberate. It feels like more than just academic oversight.
It's hard not to suspect that. We have to circle back to the idea of control. The narrative of scarcity, of looming water wars, is an incredibly powerful tool.
A tool for what?
For global control, frankly. Fear makes people compliant. If you convince populations that a fundamental resource like water is running out, you can justify almost anything. Massive government spending on centralized projects, rationing, higher prices, restrictions on land use, even forced relocation creating climate or water refugees. It centralizes power.
And knowing that abundant local water might be available, that undermines the fear narrative completely.
It pulls the rug out from under it, and it makes the continued push for certain solutions look utterly illogical, especially massive desalination plants.
Right. Why spend billions on these huge energy-guzzling factories to purify seawater if clean water is already underground?
It's financial insanity, driven by the same interests that profit from big infrastructure. Desalination costs hundreds, sometimes thousands of dollars per acre-foot of water produced. It consumes vast amounts of energy, usually from fossil fuels. And crucially, it doesn't just make fresh water.
It makes that toxic sludge you mentioned earlier.
Exactly. Massive quantities of super concentrated brine full of salt, chemicals from the intake water, and the chemicals used in the desalination process itself. Dumping that back into the ocean creates dead zones. Dumping it on land contaminates soil and groundwater. It solves one problem by creating another huge, expensive environmental problem. It makes zero sense if a clean, natural alternative exists locally.
Aldous Huxley, the Brave New World guy, he actually wrote the foreword to Salzman's book back in 1960. He saw this coming, didn't he? The resistance to a simple solution.
He absolutely nailed it. Huxley pointed out that powerful vested interests, intellectual, financial, political, will always fight against a simple, useful truth if it threatens their position or profits.
Who were these interests, according to him?
He listed them. The academic experts, whose reputations are built on the old dogma. The engineering firms and contractors who make billions from large-scale construction. The bankers who finance these mega projects. And the politicians whose power is tied to controlling these centralized systems and appeasing these influential groups, they all have a deeply ingrained incentive to maintain the status quo of scarcity and complexity.
So the listener, you hearing this now, you've been presented with the evidence, the counter-narrative. You know the official story might be deeply flawed. The challenge really is, now that you know water scarcity might largely be a manufactured lie, and a potential solution is literally right beneath your feet. What do you do with that knowledge?
Ultimately, this knowledge points towards self-reliance, toward looking down into the earth rather than just up at the clouds or relying solely on distant controlled surface systems. It encourages critical thinking about the information we're given.
It's about questioning the narrative. Maybe talking to local drillers, looking into the geology of your own area, exploring possibilities beyond the mainstream assumptions.
It's an act of nonconformity, really. Rejecting a system built on potentially manufactured fear and dependency, it's about reconnecting with the idea of a living, abundant Earth.
And maybe it starts with that simple, profound question Pal Power kept asking.
Right. The next time you hold a glass of water, just pause and really think, how can two energetic gases, hydrogen and oxygen, exist as this calm, life-giving liquid? The answer isn't just in the chemistry lab. It might be intrinsically linked to the immense pressures and generative processes happening deep within the living planet itself.
For me, the two biggest takeaways are just staggering. First, the sheer scale, potentially 5 times the ocean's worth of water locked away. And second, the purity, the idea of accessing water that's never been touched by surface pollution. It's revolutionary.
It really is. And it underscores the importance of questioning paradigms, of seeking information beyond the officially sanctioned channels. Keep digging deeper.
We highly recommend you look into the sources mentioned. Like Salzman's book, New Water for a Thirsty World, check out resources from the Primary Water Institute online if you want to explore this further. Continue your own deep dive.
Absolutely. Don't just take our word for it. Explore the evidence yourself.
Thank you for joining us on this exploration of what might be the world's greatest hidden secret. We hope it's given you a lot to think about. We'll see you on the next deep dive.